Okay, so back to oxidation states. So if we wanted to know what's the oxidation number of the carbon in CH4, then we call the unknown, the one we're solving for, the X. And then we write an equation. So X, we know H is +1. It's one of the rules, unless it's linked with something that's more electronegative than itself, or less electronegative than itself, and it isn't. So it's going to be +1, and there's 4 of them. So X plus 4 times 1 equals 0. So X has to equal -4. So if you look in the notes at the steps, it says assign the common oxidation numbers, like this hydrogen that we know. The total has to be the total charge on the compound that you're looking at. So if it's a molecular compound, it'll be 0. If it's an ionic compound, it'll be the charge of the ion. And then you solve for, let the unknown be the X, and then you solve mathematically. So if you look at example 2, it's MnO4 -1. And we're trying to solve for Mn. So you're going to call it X. And oxygen is going to be, -2. So 4 times -2. And this time, the charge is -1. So you have 4 minus 8 equals -1. X should equal 7. So the oxidation number for manganese is +7. Okay? Now, there's 2 other little factors. So you might be saying, but what does this have to do with redox reactions? Well, what it has to do with redox reactions is that if the oxidation number of an atom or an ion changes during a chemical reaction, then it means there's an electron transfer. Okay? So back when we were looking for an earlier sheet, back when we were doing these, right? The like Ca would be 0, and now it's 2 positive. So it's changed, which means there's a redox reaction happening here. It's the same thing as saying the charge changed. It's just that when we get into more polyatomic ions, maybe, or things that shouldn't have charge, like here, I assigned charge to this guy, even though he was a solid, right? I pretended, okay, let's break him up and make him, so really I was putting oxidation numbers on here because it wasn't an aqueous, but I made it an aqueous just because we hadn't talked about oxidation numbers. So if there is a change in the oxidation number or a change in the charge of an atom or an ion, then it means that a redox reaction has occurred. So if we take a look, 0 to +2, the oxidation number went up, and when the oxidation number increases, it's oxidation. +1 to 0, the oxidation number went down, and when the oxidation number goes down, it's reduction. So if you go back to your initial definitions of reduction on this sheet, of reduction and oxidation, under reduction, the last piece that we want to add there, so it already says a reaction which produces a metal from its naturally occurring compounds, and you wrote in that it involves a gain of electrons. So now we're going to write in that it also involves a decrease in the oxidation number. That's for reduction. Then on the next page, for oxidation, it already says a reaction where a metal is converted into a metal compound. You wrote in that it involves the loss of electrons, and you are now going to write in that it involves an increase in the oxidation number. Okay? So we use them to help us figure out if a redox reaction is happening and which entities that it's happening to. So your practice stuff for tonight will be on the oxidation states and numbers worksheet, I believe it's called. And there are 6 questions there, but maybe for tonight I'll just ask you to do numbers 1 to 4. Okay? Oxidation numbers. Perfect.